Hello, and today's learning target is I can solve quadratics by completing the square, day 2. So let's recall the steps of completing the square. So step 1, if you have a coefficient in front of x squared, call it a, you need to divide the sides by a, both sides by a. The leading coefficient must be 1. Step 2, isolate the x squared and bx terms. Step 3, add c to both sides of the equation so that x squared plus bx plus c is a perfect square. And do you recall how to figure out c? Yeah, you take half of b and you square it to figure out what c should be. Step 4, factor, and this should be an easy method because you should know what that perfect square trinomial factors into. And then step 5, solve by using the square root property. So let's take a look at the first example, completing the square with an ax squared. So now what's different about today is that we have a term or a number in front of x squared that will not be 1, so different than what we've practiced before. So I'm going to zoom in here, and the first thing we must do here is divide everything by a -2 because we want that first term, like I said, to be, and my stylus isn't working, there we go, to be a 1. So when I do that, I get x squared minus 18x plus 5 equals -12. So everything was divided by a -2. Now I want to isolate my x squared and bx terms. Excuse me, I don't have an ax squared, I just have an x squared now. And I'll go ahead and move the 5 over, so I'll subtract 5. And I get x squared minus 18x, and now I know I'm going to have to figure out some value to get a perfect square trinomial. So I'll go ahead and say plus c right now equals -17 plus c. Okay, and now to figure out what c should be, I'll take half of b, so half of -18, right? So over here, -18, let's fix this. I apologize, my stylus is not working properly. So that would be -9 squared, which would be 81. So here I have x squared minus 18x plus 81 equals -17 plus 81. And then to factor that left-hand side, that will factor into the quantity of x minus 9 squared equals -17 plus 81 is 64. Okay, so now I've factored. So now I can use the square root property. So I can take the square root of both sides, because how do you undo something being squared? Well, you take the square root. So I'm left with x minus 9 equals plus or minus, the square root of 64 is 8. So now I'll go ahead and isolate x by adding 9. So I get x equals 9 plus or minus 8. So this problem actually will come out with integer value answers. So here, 9 plus 8 is 17, and 9 minus 8 is 1. So I got integer value answers, but many times we won't get integer value answers when we want to solve by completing the square. So let's go ahead and take a look at another example. Okay, let's look at this second example. I see 4x squared plus 9x minus 1 equals 0. So I'm going to go ahead and divide everything first by 4 and get x squared plus 9/4 x, I'm going to leave that as a fraction, minus 1/4 equals 0. Now I want to isolate my x squared and bx terms. So I have x squared plus 9/4 x plus c equals 1/4 plus c, so I move that to the other side. Now to figure out c, I'm going to take half of b, so 9/4 times 1/2, right? So same thing as dividing by 2 is multiplying by 1/2. So 9/4 times 1/2 is 9/8. So that's half of b, but then I have to square it. So 9 squared is 81. 8 squared is 64. So 81/64 is what c will be. And I know we have many fractions that we're dealing with here, but bear with me, you can do them. So x squared plus 9/4 x plus 81/64 equals 1/4 plus 81/64. Okay, now I'll factor the left-hand side. So what does x squared plus 9/4 x plus 81/64 factor into? We'll go back and take the square root of 81/64, and that was 9/8, and then we have to keep the same sign of our middle term, and we have a positive 9/4 x, so this will factor into x plus 9/8, the quantity squared, equals, now if we add 1/4 plus 81/4, if you have a calculator, you know how to add that, go for it. If you don't, we'll have to get a common denominator of 4 and 64. That would be 64. But if we add those two up, we get 97/64. Okay? So now we're on the next step of using the square root property, so taking the square root of both sides, because how do you undo something being squared? You take the square root, and then what I'm left with is just x plus 9/8 equals plus or minus the square root of 97/64, and that doesn't come out evenly, right? Because you can't take the square root of 97, although you could take the square root of 64, right? So let's go ahead and simplify that a little bit more. So I still have x plus 9/8 on the left-hand side equals plus or minus the square root of 97 all over 8, right? Because we know the square root of 64 is 8. So now we actually see a common denominator, right? 9/8 and square root of 97 over 8. What do you see for a common denominator? Yeah, there's 8, right? 8 in both denominators. So I'm going to subtract 9/8. So I'm going to isolate x and get, I don't need that line, x equals plus or minus, well, pardon me, hold on. Got to put something before that. Negative 9/8 plus or minus the square root of 97 over 8, right? So all I'm doing is I'm leaving my terms as they are. But then, since I have a common denominator, I can write my numerators together, and I can write this actually as one term. And so x equals negative 9 plus or minus the square root of 97 all over 8. And so that would be my answer in simplest radical form. Or if I type that into my calculator, here's what I'm going to type. I'm going to type in negative 9 plus the square root of 97, hit enter, and then divide by 8. And then for the second one, I'll take negative 9 minus the square root of 97, hit enter, and then divide by 8. And what I get rounding to the nearest tenth would be x equals 0.1 and negative 2.4. Confirm that you can do that on your calculator, because you will need to do that for this work, for this practice, for 9.4 day 2. Now, the reason completing the square is so great to use to find these solutions exactly rounded to the nearest tenth, or perhaps in radical form, is because these equations, or these quadratics, don't come out to be integer value answers. But we know by graphing, by using the graphing calculator, that we can actually find those exact values. But let's say we don't have a graphing calculator, you can't use one. Well, another method to use would be completing the square. Thanks for listening to 9.4 day 2, completing the square with an ax squared term, and have a great day. Bye-bye.